All right, so today we're talking about solving compound inequalities. So we'll solve compound inequalities containing the word and graph their solution set. So visitors 4 years of age and older have to purchase a ticket to visit a certain history museum. Visitors less than 18 years of age can purchase a youth ticket. If V represents the age of a visitor, we can write two inequalities to represent when a youth ticket can be purchased. So we could say 4 years of age or older would be V is greater than or equal to 4, and less than 18 years of age would be V is less than 18. So the inequalities V greater than or equal to 4 and V less than 18 can be combined and written without using and. So we could say 4 less than or equal to V, and V less than 18. All right. So when considered together, two inequalities such as h is greater than or equal to 52 and h is less than or equal to 72 form a compound inequality. A compound inequality containing and, the word and, is only true if both inequalities are true. Its graph is where the graphs of the two inequalities overlap. This is called the intersection of the two graphs. So for example, if we have x is greater than or equal to 3, this would be the graph. And if we have x is less than 7, this would be the graph. So the graph of x is greater than or equal to 3 and x is less than 7 would look like this. It's the spot where they overlap, okay, where it's true for both of them, okay? And we could read this as x is greater than or equal to 3 and less than 7. Or x is between 3 and 7, including 3. All right. So let's take a look at an example. It says graph the solution set x is less than 2 and x is greater than or equal to -1. Well, x is less than 2 would be a circle, open circle at 2 going to your left, and x is greater than or equal to -1 would be a solid dot at -1 going to your right. Now the section where they overlap, that's true for both of those, would be the graph. So a solid dot at -1 and a line connecting to an open dot at 2. So this would be the graph. And we would rewrite that like this. Okay? All right. Here's another one. We have the graph, we need to solve it and then the solution set. So when you have a compound inequality that looks like this, we break this up into two inequalities. So we break it up this half first. That would be -1 is less than x plus 2. We would subtract 2 from both sides, just like you would solve an inequality, and get -3 is less than x. Then we take this half and solve it. X plus 2 is less than 3. We subtract 2 from each side and we have x is less than 1. Now we can graph those. So -3 is less than x and x is less than 1. The section where they combine is the graph that we want, which is right here. Okay? So this would be the graph. You would have an open circle at -3, an open circle at 1, and a line connecting them. And this is how you would represent that. -3 less than x less than 1. Okay? All right. So let's look at this one. We have -2 less than or equal to x minus 3 less than 4. So we would break this up. We would say -2 is less than or equal to x minus 3. And we would have x minus 3 is less than 4. So I would add 3 to both sides, and I get 1 is less than or equal to x. I add 3 to both sides, and I get x is less than 7. So I take a look at a number line, and I have, let's say, 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, x is greater than or equal to 1. So we would put a solid dot on 1, and we know we're going to the right, okay? And then we have x is less than 7. So that would be an open circle at 7, and that goes to the left, okay? Well, they actually combined, and you would have this, because nothing to the right of 7 would work, because it doesn't work for this one. And nothing to the left of 1 would work, because it doesn't work for this one. So therefore, this would be the graph. And we would simply say that, we could say that we could represent that as our solution set. Okay? All right. So write a compound inequality for each graph. So now we have the graph. We need to write an inequality. So let's see what we have. Let's take one section at a time, one end at a time. So this is an open dot at -3 and goes to the right. Okay? So I would represent that by saying x is greater than -3. Okay? Then this side I have a closed dot going to the left. So that would be represented as x is less than or equal to 3. So now I have to put this together. Okay? So I could say -3 is less than x, which is less than or equal to 3. And if I put that in proper notation, it would look like this. Okay? And this is what we're looking for. All right. So this one says 2 times the number plus 1 is greater than 5 and less than 7. So let's take a look at what that is. We have 2 times the number, so that's 2n plus 1 is greater than 5. So that's greater than 5. And so 2n plus 1 is less than 7. So I have those two to work with. Okay? So let's take a look at what we have. We have 2n plus 1 greater than 5. Subtract 1 from both sides. 2n is greater than 4. Divide both sides by 2. N is greater than 2. And then 2n plus 1 is less than 7. Subtract 1 from both sides. 2n is less than 6. Divide both sides by 2, and n is less than 3. Okay? So I would write that as, let's see, 2 is less than n, and n is less than 3. And in proper notation, it would look like that. Okay? All right. And another way to write that, again, could be to start out with. Instead of writing 2 separate ones, I could have done let's see, like this. 7 is greater than 2n plus 1 is greater than 5. And then broke it up into this and solved it. Okay? Either way. All right. If you got any questions, let me know. Have a great day.